Good afternoon. My name is Mary Brunkow, and I'd like to thank you all for being here at ISB as well as online with our Zoom webinar for what I think will be a great talk and conversation with Katie Hafner. A veteran of the New York Times, Katie is an author of 6 nonfiction works exploring diverse frontiers, from the origins of the internet and the world of computer hackers to German reunification and the life of Glenn Gould. That's quite a variety. Katie is an acclaimed journalist, novelist, and the co-founder and host of the Lost Women of Science podcast. Today, Katie will talk about the Lost Women of Science initiative and how her work focuses on illuminating the remarkable lives and legacies of female scientists whose contributions have been overlooked throughout history. So welcome, Katie. Thank you for being here.
Thank you. So thank you so much for having me. This was really fun because last night, I got a call like months ago from Joe Meixter saying, we want you to do this event with Mary Brunkow, and she won the Nobel Prize. And I said, wow, that sounds like fun. And then he said, maybe you could also talk about Lost Women of Science. And I said, that sounds like even more fun. So we're going to start with a door prize. So who can name for me an overlooked female scientist who is not any of those you read below? Any guesses? Any hands? Oh dear. Really? Oh, yes. Say again.
Rita Colwell.
Rita Colwell. I don't even know who that is.
She's a microbiologist who worked on the Rio cholera development.
Did everyone hear that? Wow, that's amazing.
Former head of NSF as well.
And former head of
NSF.
Oh, former head of NSF. Is she still alive? Oh, that's a problem because because one of our criteria to be featured in Lost Women of Science is you have to be dead. So. But that's wonderful to hear. Maybe she should check back in with us after. Does anyone have any others? Yes, Barbara McClintock. Another. Wait, she's alive. Oh, she's not. Oh, okay. That's a good one. Well, we only have one door prize to give out, but I do have a runner-up prize. So catch me afterwards, and I'll give it to you. It's I'm not going to give away what it is because it's very exciting. So this is what we do. Let me just explain us to you. We are a 501c3. We're a nonprofit, very much like ISB. We're a nonprofit, an educational nonprofit. And even though we're journalists, we're opinionated because that's our prerogative. But we do tell our stories quite objectively. We do actual reporting, and we're a podcast, but we're a full initiative. And I'll get later into the other things that we do. This is our sort of our raison d'etre. We truly believe, we started about 6 years ago with seed money, first from the Gordon and Betty Moore Foundation, and now we're funded mainly by the Sloan, Alfred P. Sloan Foundation. And we believe very strongly that for every Rosalind Franklin or Marie Curie whose story has been told, we currently have about 425 women in our database, all of whom deserve to have their story told. And I get pretty cranky when people think that if they know about Rosalind Franklin or Marie Curie, they know about all the amazing female scientists out there because it just isn't the case. There are many reasons, historical reasons, which I'm sure many of you can guess why this sad state of affairs has followed us through history. the way we started is with Dorothy Anderson, and I will tell you her story very briefly. She went to medical school in the early 1920s. She studied at Mount Holyoke, one of the Seven Sisters, which were quite well known for educating women in science, starting in the 1800s. And she went to Johns Hopkins for medical school. She wanted to become a surgeon, but she was blocked from doing that because she was a woman. Patients in those days didn't want female clinicians. They didn't want to be treated by women. So the women had to go to these sort of invisible places in medicine, and one of them was pathology. So she became a pathologist, which we are very, very grateful for, because then she was hired by Columbia. She was working at Columbia Babies Hospital. And I am going to play for you. Oh, I'm just praying that this works. This, I believe, is part of our trailer.
Cystic fibrosis back then
was just considered a death sentence.
It feels like you're suffocating to death.
Dorothy Anderson.
She was the first to diagnose CF in a living patient.
She was down in the basement in Babies Hospital doing these autopsies.
The first to recognize that CF was a hereditary disease.
I mean, she's just brilliant, and she put this puzzle together.
Dorothy Anderson was able to push the boundaries.
She was kind, intelligent, and very bossy.
I don't know if you could hear that. What her mentee, Celia Ora, said, she was kind and intelligent and very bossy. So what's most interesting about Dorothy, who was she's the one who sort of kicked off this entire initiative, because the woman who I started Lost Women of Science with is very close friends with the daughter of Dorothy's mentee, Celia Ora's. And this friend, Amy Sharf, said, let's write a book about Dorothy Anderson. And I said, I don't think I want to write a whole book on Dorothy Anderson, but let's do a podcast. And so that is what started all of Lost Women of Science. And she was, this is the thing about science and keeping an open mind, because back then, believe it or not, or you guys probably know this, cystic fibrosis was routinely misdiagnosed as celiac. And she would routinely do these autopsies on these babies who had died. And she was doing one day in the basement. We call this season the pathologist in the basement of Babies Hospital. And she saw the lung involvement. And then she went on this quest to figure it out. And she wrote a single author 50-page paper naming the disease, cystic fibrosis, and describing it, and lost. And I mean lost. There's something in science. Has anyone heard of the Matilda effect, which is this term coined by Margaret Rossiter, a science historian, where a man basically takes credit for the work a woman has done, and Dorothy falls into that category. And so we told her story, and then, oh, there she is. You can see that it's definitely a man's world. There she is. And these are some others that we've done. The one on the lower right, Leona Zacharias. Are any of these people familiar to you guys? It's okay if this is why we exist. And I'm actually happy to hear that you don't know who they are, because that's what we do, is we bring their stories to light. So Leona Zacharias was actually my grandmother. And the story behind all of that is that she was, my grandfather was a very famous physicist. He invented the atomic clock. He worked on the Manhattan Project. And when I was little, we just were kind of interested in his work and his career and knew nothing about hers until after I started Lost Women of Science. I thought, wait a minute, I think she did something interesting. And it turns out, indeed, she did. She, in the 1940s, was working at the Massachusetts Eye and Ear Infirmary in Boston. And she was part of a team that was looking into this epidemic of blindness among premature infants called, at the time, retrolental fibroplasia, and now it's called retinopathy of prematurity. And it was a complete mystery why these babies who were born with perfectly healthy eyes and eyesight, such as Stevie Wonder, were going blind. And I'm actually not going to tell you the answer because you'll have to listen to the episode, or at least. But it was quite a mystery, and it was very it was hard to figure out. So our motto is, we're not mad, we're curious. Okay, we're a little mad. So how do we choose someone who's lost? I say that what we have is a spectrum. And on this end of the spectrum are women who are so lost that all we really have is their name. That's it. And then on the other end are our friends, Rosalind Franklin and Marie Curie. It's like, okay, you guys, you're good. You're done. So our sweet spot is sort of in the 5, 6, 7 range, where they've done something foundational, in some way have shifted our understanding of something. They've been overlooked, and that there's the all-important archival material, meaning we have something to work with where we can tell their story. And that is one of our main frustrations, is that with a lot of these people, like Dorothy Anderson, for instance, left behind almost nothing. At Columbia, there's this folder this thick of just sort of cards from grateful parents of patients whose lives she saved. And that was a very hard one to put together. As of today, which we're super proud of this, we have a database of 426 scientists, all of whom deserve to have their stories told. I was up talking to the board earlier, and we're exhausted. We're a teeny tiny team, so we all feel like Erin Brockovich, and it's just like knocking on doors, like one woman at a time, just one woman at a time. Also, we have an emergency tip line. So, a ringing phone graphic on our website, and we get people calling. And a lot of them are men who call and say, this woman's story has to be told. And I can't tell you how many women we've found that way. It's incredibly gratifying. So PRX is our, the podcast is on the PRX podcast platform, and we publish in partnership with Scientific American. We do these other things as well. We do deep dives. We do conversations, and if any of you have any ideas for conversations, we have conversations with authors of books about women whose stories haven't been told. The Black Angels is an amazing story of women who were treating tuberculosis as Black nurses in New York. It's a crazy story. Other things we do, as I said, we're a full initiative. My husband makes fun of me. How's your initiative? And one thing we're doing is this is exciting. So we commissioned one of our episodes was a two-part story that we told about Lisa Meitner, the atomic physicist who split the atom and worked in close collaboration with Otto Hahn. He got the Nobel Prize. She did not. She was, in fact, nominated 49 times and did not get it. In fact, she was Jewish and had to leave Berlin, and she was in exile in Stockholm when the prize was given to Otto Hahn, and she was sitting basically in the front row, and he didn't even say her name. And what's important about the science is that he was the chemist, he did the experiments, and she was the theorist. And they did not set out to split the atom, but he was doing these experiments. He saw something strange happening, and she figured it out. And she explained to him what he had found. And so this play that we've commissioned, the title is Fission. and it's being put on by Seattle Rep. One of our board members is also on the board of Seattle Rep, and she went to Seattle Rep, and they are doing it, and it's very exciting. Damaso Rodriguez, who's the artistic director, he's actually directing it. So we've got that going. We have a nice grant from Craig Newmark for our Wikipedia project, where we update, create, and revisit. We like to say we're not correcting the historical record, we are revisiting the historical record, and we do that on Wikipedia. Some of these Wikipedia pages for these women are not just wrong, they're embarrassing. And so we have a collaboration with the Smithsonian's new American Women's History Museum, and we get together and we love it. If anybody's interested, I don't know if any of you have done any Wikipedia editing, it's actually a lot of fun. And so we do these edit-a-thons with them. We have a children's book series with Penguin Random House. This is actually the door prize. And it's signed by me and Mary. So it will be very valuable. And we have three books coming out, and we have 10 women per book. And this is volume 1, and volume 2 is Penguin Random House has been just wonderful. And so we're going to be doing 30 women in total. And then we work with schools. We go in to, and I'll show you some pictures, we go into classrooms, and students work with the stories and tell and learn about the science through telling these stories. And it's hugely gratifying. Here are the books. This is number 2 on the right. And then that's Amy. We have a whole thing that we do with the Lycée Français in New York. And doesn't it look like story time? And that's her talking to the kids. The other thing we do, which is really important, and I know that you're going to appreciate this as scientists, is that we don't dance around the science. We make sure that we can communicate the science in a way that works. And I'm going to play for you this one, oh shoot. Wait, I know I can get to, oh, I got it. Wait, almost. Oh, got it. I'm going to play for you this one clip. So our second season was about Clary von Neumann. Does anyone know who that is? It's fine if you don't. But you know who John von Neumann was. Oh, you really aren't computer science. Oh, you, okay. Yeah, okay. A couple of people know. So he was a very famous mathematician and just absolute genius and computer scientist. And he actually taught his wife, Clary, who had never even been to university, basically to program. She became one of the first programmers. And so one of the things that they figured out together was the Monte Carlo method of statistical probability. And it's really hard to explain. And they met in Monte Carlo, and so it's called the Monte Carlo method. It's not I don't think it's named for where they met and fell in love at the bar, but here's how we explain it.
The Monte Carlo method imagines many possible outcomes of a particular event, like the motion of particles. And then it simulates the event over and over again to determine the probability of each outcome. It uses randomness to solve problems. For example, say you're sitting at that roulette wheel in Monte Carlo placing your bet. The ball will land in one of 37 slots. But what would it take to derive an equation accounting for every variable? The ball's initial position, its kinetic energy, its angular momentum, and all the other factors, the friction acting on the ball, the ricketiness of the table, the crookedness of the house. It's reasonably simple to state mathematically how each individual factor shapes the odds for what the ball will do in the next small fraction of a second. Spin smoothly, deflect from an obstacle, or settle in a landing slot. But deriving a single equation to predict the odds for final landing positions directly from starting conditions is much, much harder. So instead, Monte Carlo uses statistics. It plays endless rounds at a simulated wheel, collects the data, and presents its findings. Meaning, with the Monte Carlo method, you're living out the possible scenarios of what could happen to get a sense of what's probable. But in simulating all of these scenarios, in walking down all these paths, the unlikely is eventually, inevitably realized. And this ability to map out not only what is probable, but also what is improbable, might be a fitting analogy for Clary's own life.
I hope so. Did you like that explanation? Yeah, we put so much work into that. And I think, I feel really strongly about explaining the science and making people sort of walk away from an episode saying to themselves, I get it. And we do that every single time. So we do a lot of archival work. We conduct a lot of our research at the Library of Congress. The problem with looking into the women is that it's often a needle in a haystack mission. Like we'll find, for instance, Clary's papers were buried with John's papers, so we had to go through all of his stuff to get to her stuff. And so we're working with the Library of Congress as we dig things up ourselves. We hand it over to the Library of Congress, for which they are very grateful. We find things in basements. We find unpublished biographies in a closet. In our latest season on Catherine Burr-Blodgett, a chemist, a physicist and chemist, we ended up finding, we thought we had nothing. And we found this trove of material in a family storage locker in New Hampshire. And so this Library of Congress is busy creating a Catherine Blodgett collection. So there's Dorothy, our hero, and Celia, her mentee, the one who called her bossy. That's Clary. I wanted to do this kind of Anne Frank thing. So that's one of the Clary's flow charts, and that's her handwriting. This is Clary von Neumann, and I wanted to sort of hide her in Anne Frank fashion. That's her passport photograph. We love our artist. We have an incredible artist named Lisk Fang, who, and I want to talk about the evolution of our art. She does a lot of her work for the New York Times, but she loves us, and she loves us. And so she gives us a great rate. And so this is about this season that we did is on Frances Kelsey. Frances Oldham Kelsey, does anyone know who that was? She was a physician and medical reviewer at the FDA in the early 1960s, and she blocked the drug thalidomide from getting into the United States, which saved thousands of lives of babies and prevented many babies from being born with these limb differences and other problems. And so originally Lisk, so there she is stopping people from taking the pill, which I love. But I wasn't so crazy about the whole Jesus pose. So this is the final piece of art, which I think is fantastic. So our most recent multi-episode season is about Catherine Burr-Blodgett, who I mentioned, and she worked, and it's interesting getting to know ISB a little bit, because what you do at ISB is a little bit what the model, it's this idea of doing science in a place that is without the burden of some of the things that you find in academia. So she worked at GE. So back in the day, meaning the early 1900s, GE had a more famous research lab even than Bell Laboratories. And so the General Electric company, which brought us the light bulb and other things. And Catherine was hired there, and she ended up inventing non-reflecting glass. So I thought I would play you the trailer. Let's see. Oh, here we go.
Have you ever heard of Catherine Burr Blodgett?
Never.
No, never.
I think she was a movie star.
I never heard of her.
Catherine Burr Blodgett. That is a name I have never heard before.
I don't know who that was. Should I?
Yes, you should. I'm Katie Hafner, host of Lost Women of Science. In this season, we are going deep into the life and work of Catherine Burr Blodgett, a physical chemist. She was doing nanoscience long before there even was such a thing.
Everything that you see today with surface coating.
Almost all optical instruments use coated lenses whose anti-reflection properties are determined according to the requirements that she elucidated.
Can I wax poetic about her for 1 second?
She must have been really brilliant to come to the attention of the research directors at the labs.
She spent her entire career at the General Electric Company, the epitome of a man's world, working in the shadow of one man in particular.
Okay, I'm going to stop it there. So that one man in particular was a chemist named Irving Langmuir, who did his main work on surface chemistry in 1918 and won the Nobel Prize in 1932. And Catherine, I think Mary and I are going to talk about this a little bit, about this idea of the context in which she worked. I mean, we're talking the early 1900s. She got her PhD from Cambridge, and I'm going to show you that picture after I show you the hallway. So here are all the men. Can you see her there? And this, in fact, so this was in 1950 when when the GE Research Lab moved into these great new quarters, and that inspired us and Lisk to do this with the artwork, and that is this whole wonderful thing Lisk did of this exploding out of Catherine's office and the shadows of the men. I love this. So here is Irving Langmuir, who I said won the Nobel Prize in 1932, and the Nobel organization decided that they were going to, in 1939, that they were going to do a series of films where the scientists explain their science to the world, and this was in 1939, so it was a long time ago, and it was very ambitious of them. And what I'm setting up here is that he was not exactly Bill Nye the Science Guy.
You need a lighted surface, and I'll ask you to look over my shoulder at the surface.
He's clearly uncomfortable. He has trouble finding words. And then he calls for reinforcements. His colleague at General Electric, Catherine Burr Blodgett, someone who knows the science as well as he does. Maybe better, actually, since she's the one who discovered this type of non-reflecting glass in the first place. She steps in to explain.
You may have been noticing the reflection from Dr. Langmuir's spectacle, but it is possible to treat glass in such a way that it will not reflect light. This is done by coating both sides of the glass with a special type of film. The film must have...
Catherine Blodgett's delivery is silken, confident. She's 100% in command of her science. She is an inspiration. But for the duration of her career, Catherine Burr Blodgett worked in Irving Langmuir's shadow.
So that's where they worked. I for some reason I'm fixated on the cars. Like, how did they get into those tight spots, right? So that was the General Electric building, and then here she is. So she got her PhD from Cambridge in physics in 1926. Although women were not allowed to actually have PhDs, so they kind of gave her some like certificate or something. And it wasn't until the late 40s that women could actually go and claim their PhD. And that guy in the second row, so this is the Cavendish Laboratory, the famous physics lab in Cambridge. Behind her in the other pink circle is none other than J. Robert Oppenheimer. So, and the rest of these people super famous physicists, or went on to be. And there's Catherine, looking earnest. And her story, I hope, if you do listen to Lost Women of Science, I say this to everyone, I hope you'll listen to the season about Catherine, because it's the season I'm just so proud of it, because I think we really took this woman who nobody really knew anything about, and told her story fully. So that's us. And I think now what we're going to do is have Mary and me talk, and then we're going to have questions from all of you. Does that sound right? Okay, good. Great.
So I wanted to ask a question. Tables are turned. I get to be the interviewer. What's the common thread you find with all of these women that you've been delving into?
You mean aside from the fact that they're dead?
Well, yeah, there's that common
Well,
element.
I know that's our criterion, because, you have to draw the line somewhere. And also, but seriously, I mean, they're not here to speak for themselves. And that's why we tell their stories as best we can for them. And the common thread, I would say, is a profound curiosity. I mean, there's every possible, imaginable discipline, field of science. We have botanists and chemists and physics and mathematicians, computer scientists, aeronautical engineers, and there's a curiosity that every single one of these women not only possesses, but pursues. And in straitened circumstances. I mean, women who set up experiments in their kitchens, and who weren't allowed to go on expeditions and snuck onto the boat. Women who weren't allowed to get married and married in secret, and then hid their pregnancy because they were so determined to pursue their science. And I'd say that's the common thread.
Yeah, not surprising. So just kind of by definition, these women are hard to study because they've been forgotten. So kind of what's your approach first of all, how do you decide which woman to focus on? And you have a really small team. Can you work on more than one at a time? What's your approach?
So actually we're growing slowly. It used to be just like 3 or 4 of us, and now we have a pretty robust team of producers. And we have meetings, and we decide we're really careful because it's such an investment. And so we decide who we're gonna focus on. And she has to have done something important. It obviously, if the Nobel Prize were a criterion, there would be 3 women ever, because back then women just didn't get the Nobel Prize. And for reasons that I won't bore you with, but you can probably guess. But if she did really important work the work itself has been recognized, but her role in it has not, then we work hard to shift that. And we do it in small ways and we do it in big ways, like with Dorothy Anderson. Columbia way back had commissioned an oil portrait of her, and then over the years the thing went missing. And so after our season came out, they commissioned us another one, which was very gratifying, like little wins like that. And also like the Cystic Fibrosis Foundation. Dorothy was a real victim of the Matilda effect. And its biggest award is named after a man, Paul de Sant'Agnesi. And they attached her name to the award as well. So, but we have to be able to make our own assessment as to how valuable her contribution was. And we have to be really careful. We cannot overemphasize it. Like we can't sort of do this sort of wishful thinking. I was telling Mary earlier that one of the things I still do for the New York Times is advance obituaries. And the obit editor called me one day very excited about this woman. And she said, oh, she did all these amazing things. And once I looked into it, I realized she didn't. And so you have to, look at things look at their accomplishments with a realistic eye as well. Does that answer your question?
It does.
Okay.
It does. That's interesting. So a superpower, obviously, of Lost Women of Science is making science accessible to a broad audience. Why do you think that's important?
Because I think science is hard. It's hard to understand, and it can be alienating, and it can make you feel a little bit diminished if you don't understand it. And it's empowering I'll never forget the moment. So I wrote a book years and years and years ago on computer hackers. And it was, I was at MIT hanging out with a bunch of smart people. And they were explaining to me how this one hack had been accomplished. It's something called the Internet Worm. It was this kid named Robert Morris who basically got a number wrong. He didn't mean to commit a felony, but he did. And the way my mind clicked when I got it, it's truly empowering. And so I think the more you can sort of take away the scary part. You guys out there, you don't know how hard it is for people like me to feel for idiots like me. Especially, I come from a family of, my grandfather, as I said, was a physicist. My grandmother, really smart. My father was a physicist. My mother was a mathematician and physicist. And my grandfather had even started the entire high school curriculum, something called PSSC, Physical Science Study Committee, for teaching physics in high school, and I would just go into the girls' room and cry. And so I think if the earlier you can start in getting kids to understand science and embrace it and want to do it, the better.
Yeah, I agree. So definitely your efforts for getting into the classroom as well must be very powerful and well accepted, I would imagine. I are kids pretty excited about what they
they love
and learn?
It. Yeah, these little kids at the Lycée Français in New York, we're like rock stars to them. It's like, oh, the people from Lost Women of Science are coming. And that's what you want to be, right? And it really helps them understand the science. We have a great internship program as well. So we take interns from high schools, and we've had interns who've been with us all the way through graduating. We have one who wrote to us out of the blue. She was a high school senior, and she still works for us. She stayed with us through her time at Carnegie Mellon, and she still works for us. And that's what we have a great continuity that way.
It's fantastic. So look into your crystal ball for me for a moment. What will the Lost Women of Science initiative look like in, say, 10 years, in 2036? And how do you think your efforts will be visible when today's students are tomorrow's scientists?
So, that door prize? Maybe we'll see a lot of more hands go up. That's my hope. So that's what I hope we do, is we sort of build this critical mass of understanding about what women through history have done in science. And as for us, I'm hoping, I love the podcast part of what we do, but listening to a podcast is a commitment, especially listening to one that isn't serial. It's like you've got to really, I love serial, but it's deep. What we do is deep storytelling, but it takes effort and commitment on the listener's part. And so I'm hoping that we will partner with a lot of people, with a lot of organizations like ISB in education and schools around the world, and what we're doing with Penguin Random House. And I'm hoping that every single Wikipedia page on all of our women is I have to confess that when I started the episode on my grandmother, she did not have a Wikipedia page. Not only did she not have a Wikipedia page, but my grandfather's very lengthy Wikipedia page mentioned her not once. And I know. And so I'm very proud to report that her Wikipedia page is 3 times longer than his. I don't know if he's on it, but anyway, that's what I'm hoping, is that it will just be almost like our wallpaper, almost as might be our new normal to understand more women in the history of science.
That's great. I have one more question. I'm just wondering, as you look at back in history, when you look at when these different women are working and the period of time where they're doing the work, do you see like a pattern and a shift in the way women in science are accepted, or, how easy it is for them to have done their work in whatever environment?
Let's do it in a 2-parter. I'm going to take it up to when you started doing your work, and then you can take it from there. So a lot of these women, as I said, if they wanted a science education, they had to go to one of the 7 sisters, and then it was hard to go on from there. You could not back then, until relatively recently, you couldn't take a job at a university. If your husband worked there, they would not hire you as a spouse. Or if you got married, you had to quit. You couldn't be pregnant. So there were all these trade-offs. A lot of our women never married, didn't, as far as we know, have a life partner. So there are no descendants for us to draw on. And it was lonely, and there was a lot of ostracism. And the men, I wouldn't say that they treated them with derision, but for instance, let's take Catherine Blodgett. I mean, the woman was brilliant. She entered college at age 15. And as I said, she got her PhD in physics, the first woman ever to get a PhD in physics from Cambridge. And she worked as Irving Langmuir's assistant. And what I say in the podcast is that it was, and I get a little bit highfalutin, and I talk about the philosopher Heidegger, and this idea of how she just accepted it as the air she breathed, that the context in which she worked, it was simply what she was his assistant. And so lifting her out of that context and saying, actually, Catherine, you lead the lab, you come up with the ideas. I don't think she would have known where to start. So when you started your pursuit of science, how would you describe the context as a woman?
I would say like thinking back to when I started graduate school, which would be a good time to start, at least in the life sciences, I saw that, more and more women were getting into graduate school and were interested in pursuing, a real lifelong career in science. And over the years since then, certainly like the percentage of women, I think, in entering classes has progressively gone higher and higher. And I think the comfort level and the ease with which women can participate in science and excel in science and be accepted has really increased. I mean, I've seen it in my career, and it would be great to talk to younger women as well to see if it's even changed more. I think what happens is that it's in a way, it's easy to get started in the field, but then we really need to pay attention to what happens as people progress and want to move into higher levels of, management or, just overseeing larger groups. What happens then? And I think there's still issues that are related probably just to, policy and the way that women's lives can be supported as they go through different, outside of work life changes. But overall, certainly things are better than back in the day of the women that you're talking about. But
Right. And yet, right, don't you think they kind of bump into this ceiling? They go only so far.
A lot of times.
A lot of
That's
times.
still an issue.
So
Yeah,
we have a ways to go. We still have work to do.
definitely.
But your advisor, Shirley Tillman, became president of Princeton, right?
Yeah, she broke through that ceiling.
Broke through that ceiling.
Yeah.
At some cost, I bet.
Yeah.
Yeah.
Yeah, I think so. But so there are extraordinary examples, of course, but we need more.
We need more.
Yeah. So should we open it up to questions?
Yes, let's open it up to questions.
Okay.
Anybody? Don't be shy.
Katie, you mentioned your grandpa and grandma were both notable scientists. Did you know this growing up? Was this, as you were a grandchild visiting, was this part of dinner conversations?
Oh, yeah.
And how has that translated into you doing what you're doing right now with this initiative?
Well, as I said, it was always about my grandfather's work because he was the famous one. And my grandmother, she was not a nice woman. If you listen, she was very, I know. Anyway, but you'll hear. In fact, I wrote an entire memoir, not about her, but about my own mother, and there were a lot of expectations on us as kids. But I do remember that these famous scientists would come. They had a house on the Cape and would come and hang around at the Cape. And there were always my grandfather was an experimental scientist, and so. And as I said, he invented the atomic clock. So there were always interesting experiments going on and science for kids books all over the place, which were a lot of fun to play with.
Well, thanks for this work. I think this is really important storytelling for a lot of reasons. But right now we're in a pretty dark time in terms of the relationship between science and society, but also cultural backsliding and loss of progress. So in that context, when I look at the history of science, I often see great progress happening when perspectives come into fields that weren't there before, like a lot of physicists moving into molecular biology in the early 1900s. But same could be true for not just scientific expertise, but women or people of color, what have you, that you see these like boosts of productivity and advances in science because of this diversity entering. Are you looking into these factors in your work? Like how have women's contributions pushed in new directions that we would not have otherwise gone in? And then how do we communicate that to society to kind of fight against this stuff?
That's a great question, Mary. Maybe it's better for you. But I can say from a historical perspective, I was just thinking about Flora Patterson, who was a mycologist and brought, I don't want to say so much a feminine perspective, but she might have looked at what she was looking at a little bit differently than a male mycologist would. Another one, there were the famous women at the Harvard Observatory, the astronomers who Davis Sobel has written about so beautifully. I think the fact that they were women doing this might have brought something a little bit extra. There's the very famous example, and I forgot to mention that we work with Margot Lee Shetterly, who wrote Hidden Figures, and we have something that Margot started called the Human Computer Project. And so the women in Hidden Figures were human computers. And so they, I don't know if I'm answering your question, but they brought something to bear on these problems. As for kind of a diversity of sort of, you're talking about a cross-pollination, right, of disciplines. That I've never even thought about, and that would be really interesting to look into. For instance, the fact that Dorothy Anderson couldn't become a surgeon and became a pathologist instead, and went into it with the famous kind of open mind that Pasteur talked about, that, don't be, I think women are a little bit less, I'm generalizing egregiously, but I think that women are a little less locked into an anchoring bias than men might be. I don't know if you agree with me on that.
I do.
You do. She does. Okay. Yeah.
I think that's true. Yeah, that is a gross generalization, but
It is.
Yeah, I think more flexibility and sort of, willingness to see things from a different perspective when necessary.
Possibly, yeah. Interesting. We should look into that more. Thank you for that.
That's a good question.
I have a few online questions I can share. I mean,
You can do that.
we can do one of them first, one of the online questions real quick. An interesting thought, and it's kind of a long question, so I'll try to summarize it well, but has your group, or do you know of anyone else that's tried to petition the Nobel Committee to kind of retroactively recognize any of those women in the past?
Oh, man. So, I mean, in the case of Lisa Meitner, we've been in very close touch with the Nobel people about mostly the Meitner case, and it's a famous case of omission. And so they're very well aware of it. They have a very hard and fast rule, is that Nobel Prizes are not awarded posthumously, which is why Rosalind Franklin did not get what she just, yeah. So, so the Nobel people, that's sort of their thing. However, there were some reparations made in Lisa Meitner's case, not Nobel specific, but she was awarded the Fermi Prize, sort of as compensation. And Otto Hahn did, even though he didn't mention her when she was sitting in the audience, he did share his prize money with her. The Nobel deliberations stay confidential for 50 years. So you can't know. Mary, for instance, doesn't to this day know who nominated her and didn't at the time and can't know unless the person comes forward for 50 years. And several generations from now, my successors at Lost Women of Science can go in and look at, I would be fascinated to actually look at their deliberations. And in Mary's case, what's great is that it's clear. I mean, this is a person who just did the science and wasn't a self-promoter and blah, blah, blah. And they did their due diligence and they knew who did the work. And in the case of Rosalind Franklin, I mean, that was unfortunate because she died. But in the case of Lisa Meitner, shame on them, truly, and others. We're doing one now on an X-ray crystallographer, a married couple named Jerome and Isabel Carl. And he got the Nobel Prize. She did much of the work. He got the prize. And he felt so terrible that he, in secret, nominated her afterwards. Yeah, it's quite a story. Yeah.
This was great. Thank
Let's
you.
make this the last question.
Awesome.
Alice,
okay.
yeah.
Incredible initiative, and I love it
Thank
so
you.
much. My question was, yay. My question was whether either of you have thoughts about, obviously, in really important work, uncovering these lost women of science, but ways that we can uplift and support and celebrate women in science who are not dead, who are current. Obviously, Mary's an incredible example, but if there are other things that we could be doing to kind of celebrate and uplift women in science generally.
Well, obviously encourage girls and young women to go into STEM, but also we want to start a new thing, and I'd love input from anybody, where we are in conversation with a living scientist about a dead one. And we're starting that. We've got a couple of grant proposals into the Luce Foundation, and one of them is to start a series like that. And so that the living scientists can get to know one of her predecessors and appreciate them from this vantage point.
That's fascinating. That will really be of great
Thank you.
interest.
Yes, that was
Great.
my idea.